Welcome back, everybody. My name's Mr. Swaner, and today we're going to be talking about slope of a line. Before we begin, make sure that you pick up your companion notes so that you can follow along to this presentation. And I'd like to start this presentation by asking you what you think of when you hear the word slope. I think of skiing. But maybe you think of stairs? Or perhaps you think of the pyramids. Maybe you think of the slanted streets of San Francisco. Or the cliff of your nightmares. Or the flatlands of paradise. These are all the 4 different types of slope, and they all have very specific names. The first type of slope we're going to discuss is positive. A positive slope goes up and to the right, and it kind of looks like stairs. So it would be something that you would have to climb up. The next type of slope is the opposite of positive, is negative, and negative is more like a slide. So you could kind of slide down it. Another type of slope, you'll see this has no pitch at all. This is an example of none. There is no slope in this line at all. And the last type of slope is when the line is straight up and down, and that is an undefined slope. So let's see if you can determine which type of slope these are. If you said none, you are correct. Let's look at another one. This is an example of a negative slope. Remember, negative goes down and to the right. This is an example of a positive slope. Positive goes up and to the right. And the last type of slope is undefined. Undefined simply goes straight up and down. So now that we can recognize our different types of slope, let's get the actual value of the slope. And we can do that by using a little formula called rise over run. And rise refers to up and down, and run describes the left and right of our graph. So if I draw my line here, if we're looking for the rise is how much it goes up and down, and the run is how much it goes left and right. And I want you to notice that I'm connecting where the line crosses on the grid points perfectly. And I put in my stairs there. And the rise in this example is 2. It goes up 2 units for every 3 units it goes left or right. So the rise over run in this situation is 2 over 3. And that's how we describe the slope of this line. The slope is 2 over 3. And I want you to notice that it's a positive 2 over 3 and that this is a positive slope. Those two things should go hand in hand. So let's look at another example. I'm going to use rise over run for any time I'm trying to find the slope. And looking at my line, I'm looking for where the line crosses on my grid perfectly. So if I start from the beginning here, it looks like it rises 1 and runs 2. I can fill this in for the rest of it. So my rise, my up and down, is 1, and my run, my left and right, is 2. So the rise over run for this line is 1 over 2, and that's how I would describe the slope of this line. The slope is 1/2. Again, I want you to notice that the slope is positive, and the description of my line is positive. That is a positive slope. So let's look at one more just like that using our rise over run. And looking at our line, we need to find perfect points where it's going to cross. And I'm going to rise, it looks like 3, and run 2 to get from point to point. And I can continue doing this on my line forever and ever. So it will rise 3 and it will run 2. So my rise over run is 3 over 2. And that's how I would describe my slope. The slope of this line is 3 over 2. Again, the line is positive and my slope is positive. So let's look at something just a little bit different. Now, remember, this is a slope of none, but let's talk about why this is a slope of none. So first I'm going to look for my rise. Well, it doesn't rise at all. It rises 0. And then if I look for my run, there really is no end to my run. So it rises 0 and it runs forever. So it's a rise of 0, run of infinity. And if we look at this, 0 over infinity, that's 0 divided by infinity. Well, remember that 0 divided by anything is simply 0. So the slope of this line is 0 or none. There is no slope to this line. So again, looking at this line rises 0, but it runs for infinity. So 0 over infinity gives me a slope of 0. Okay, let's look at another example. Now, we should know that this is a negative slope just by looking at it. And we're going to do the same thing. We're looking for point-to-point, perfect points of where this graph crosses. And I'm going to draw that in. And you see I have a negative rise in this case. I'm not rising up, I'm rising down. And my run is still going to the right. So I can connect points just like this, and this will go on and on and on forever. So I have a rise of negative 4. This graph is going down 4 and to the right 3 to cross perfectly. And it will go down 4 and to the right 3 forever. So my rise here is negative 4 and my run is 3, making my slope negative 4 over 3. Let's look at another one here. So here's another graph. I need to find the rise over run. And it looks like I can go down 1 and to the right 3 to make it to my next perfect point. So I can continue doing that. And my rise, again, because I'm going down, my rise is negative. So that's a negative 1. And the run is 3. And that will continue. So my rise over run is negative 1 over 3, which makes my slope negative 1 over 3. Here's another one. So we're just looking for the slope. We're looking to see where it crosses. It looks like I can go down 1 and to the right 1 each time in this case. So my rise is negative 1 and my run is positive 1, making my rise over run negative 1 over 1, which means my slope, remember that negative 1 over 1 can be simplified to just negative 1. Here's another example for us. We've got a very steep negative slope, but we're going to do the same thing. We're going to see how we can get from point to point. It looks like I can go down 2 and to the right 1. So I'm going a negative 2 and then to the right 1, and that will continue. So my rise is negative 2, my run is 1, which would make my slope negative 2 over 1. And remember that negative 2 over 1 can be simplified to just negative 2. Here's our last example. I've got something that is undefined, but I want to talk about why. So when we're looking for our rise, it looks like it rises forever. It doesn't stop, and it runs 0. It doesn't run at all. So if I'm going to input my rise over run, it rises infinity and runs 0. And we have this old rule that says we can't have 0 in the denominator because it just doesn't make any sense. So our graph is called undefined for this reason. So the slope of this line is undefined. That's our lesson. Let's see what you remember. There are 4 types of slope. Can you name them and draw a quick sketch of what they look like? I'll give you 1 second to just go ahead and do that. And hopefully you remembered all 4 kinds. So the first kind is positive. The next type is negative. Then we have the slope of none or 0, no slope. And the last type is undefined. And lastly, we also discussed how to find the slope of a line. And that can be done using a formula. And that formula is, if you said rise over run, you are absolutely correct. Well, thank you very much for joining me. Again, my name is Mr. Swaner, and until next time, study hard and keep practicing.